Today I'm going to show you parts of our pilot study on the deployment of cholera RDTs and the integration of the RDTs into the surveillance system in DRC and Niger. So cholera RDTs have proven to be very good for the surveillance. That's why Gavi started to distribute in 19 countries already RDTs step by step. And these RDTs are mainly for surveillance, so they're not for individual patient diagnostics. In the most recent guidelines from the GTFCC, the Global Task Force on Cholera Control, they already introduced those RDTs for surveillance, however, in a rather theoretical concept. So the goal of our study was to test this theoretical concept the very first time in a real-world setting, and then kind of develop a recipe which we can give to the countries or like support the countries then who receive the RDTs to integrate those in their surveillance system. For that, we conducted an observational mixed method study in DRC for 1 year and in Niger for half a year. So the first objective was to evaluate the performance of the RDT, so the tool itself at the end users in the cholera treatment centers with nurses. So for that, we collected stool sample from each suspect case arriving in the CTCs in 6 different health zones in DRC. And we tested this sample with 3 different RDTs, first direct and also with enrichment step beforehand. And additionally, we also tested them with culture and qPCR. Considering the performance of the RDTs, you see that the direct RDTs reached a sensitivity which was pretty similar for the 3 of them, and which ranged from 76 to 81%. Now for the specificity, the ST BioLine reached a significant higher specificity compared to Crystal VC01. Now by adding this enrichment step beforehand and then performing the RDTs, this resulted in a decrease in sensitivity for all the 3 tests, which was significant for ST BioLine and Crystal VC01. And for the specificity, it led to an increase, which was only significant for Crystal VC01. Considering the TPPs from the GTFCC, none of the RDTs, neither direct nor enriched, reached a TPP of 4 sensitivity, whereas for the specificity, ST BioLine, direct and enriched, and Crystal VC01 reached the TPP. Now, the current problem with cholera outbreak detection is that the outbreak has to be confirmed with a laboratory sample, which is then analyzed by culture or PCR. Now, in cholera endemic settings, these lab capacities are rather limited. And additionally, you have from rural areas until they arrive in the lab, you have a very long time. This is in addition to the rainy season, or cholera is often a rainy season, so the transportation takes a long time, and cholera outbreaks are often confirmed only weeks to months after. Now, a possible solution for that was presented in the most recent guidelines from the GTFCC. They introduced a threshold, which is a tool to identify a probable outbreak, now which considers already the imperfect performance of the RDT themselves. And by identifying a probable outbreak, this should be already enough to trigger all cholera-related interventions. So this kind of theoretical concept, we tested this the first time in a real-world setting. And we have done that in 2 different surveillance units in DRC, where we trained the surveillance officers in how to use this tool. Now, a probable outbreak is detected if within the past 14 days, a certain amount of RDTs are positive. So for example, if from 3 to 7 RDTs, or like cases tested with an RDT, a minimum of 3 are positive, the chance is very high that at least 1 out of those 3 is correctly or true positive. So I'm going to show you an example how they used it in DRC, in Mulonga, which is in the ex-Katanga region. So it was on the 26th of July, they detected the first 2 cases. But the problem was that they didn't have any RDTs in this area. So the surveillance officers, it took them a while to send RDTs in this area. And after a couple of days, on the 1st of August, they managed to test the very first patient, and this patient was positive. After another couple of days, they tested more, and by the by the 8th of August, out of 5 cases tested, 4 were positive, and because of that, the threshold was reached, and the surveillance officers declared a probable outbreak. So in conclusion, the surveillance officers successfully identified themselves a probable outbreak, and they used a calculation aid on paper form, which we provided to them. Now, for outbreak monitoring and burden estimation, the main problem is the broad case definition for cholera. This broad case definition includes a lot of non-cholera cases, which are other diarrheal diseases. And for example, if you see here below, it's a theoretical outbreak, cholera outbreak, the epicurve. You have the suspect cases per week. But we don't know how many of those are now real cholera and how many are other diarrheal diseases. So by using the RDTs, we can quite easily distinguish between the two of them and actually follow the dynamics of the outbreak much closer and much more correct. And for example, if we need to prioritize after something like a vaccination, we can compare the incidence based on the RDTs from different areas and then decide where we want to target. Now, the problem with the RDTs themselves is a short shelf life of below 2 years, then the supply and the cost of them. So a possible solution for that is the use of a sampling scheme. So a sampling scheme is basically just the testing of not all the cases, but a subset of the cases. So by testing a subset of cases, we can then define the positivity of those cases and multiply them by the number of cases, and then we get the incidence based on the sampling scheme. Now, the third objective of our study was to identify the best sampling scheme, which leads to the incidence, which is the closest to the incidence when we test everyone. And a possible, an example of such a sampling scheme is given in the latest guidelines from the GDFCC, which is the testing of the first 3 cases arriving per day by CTC. So to identify this sampling scheme, or the best sampling scheme, we, based on our data we collected in DRC, we calculated the weekly incidence with the sampling schemes from 8 different sampling schemes and 21 sub-schemes. And then we used a couple of different statistical indicators, such as precision, accuracy, and so on, to identify which incidence is the closest to the incidence by testing everyone. And in the end, we ranked then these different sampling schemes to identify the best sampling scheme among them. Now, everything is very theoretical, but it's very important also to consider reality. So eventually, theory and the reality is often different. So what we did for that is that we tested a couple of different sampling schemes in the real world, in DRC and in Niger. And the main lesson was, or we learned from this experience, was that actually it's rather difficult to implement such a sampling scheme. And it needs a lot of training, a lot of supervision. But with that, then actually, if you implement a simple sampling scheme, it's possible to do it. So by considering this statistical, but also real-world observations, we figured out that the sampling scheme recommended currently by the GTFCC, which is testing the first 3 cases by day by CTC, that this sampling scheme is actually among the most accurate ones and is possible to implement. And by implementing this sampling scheme, we can save up to half the RDTs. Now, towards the end of the study, we conducted a couple of focus group discussions and individual interviews with nurses up to policymakers at national level to get their experience and their return on the integration of RDTs into the surveillance system. For me, the most striking result from the whole study was mentioned by a nurse from Mulongo, and she mentioned that even the community did not know that cholera existed before. Now, by using the RDTs, or by having the RDTs, the community is really convinced that this disease exists. And as you all know, you cannot stop a cholera outbreak without the support of the community. A couple of other findings showed the importance of training. So training and supervision is the most important, especially for cholera, since cholera is seasonal. So we have a long period where you have no cholera cases, and every one of you know that if we don't do something regularly, we tend to forget. So in conclusion, the RDTs were highly recommended and appreciated by the community, to the nurses, up to national stakeholders. Stool enrichment for surveillance is not recommended, considering the loss in sensitivity, the additional time and costs, and the processing time. Then the identification of a probable outbreak using this new threshold tool was successfully done in our study. And this threshold actually showed to be a crucial epidemiological tool, which gives the power to the surveillance unit to identify independently a probable outbreak and then request for support. Then the best sampling scheme, combining statistics but also real-world observations, showed that testing the 3 first cases per day by CTC is the best sampling scheme. Now, using this sampling scheme in CTCs in the medium and high incidence settings can save 1/3 up to half the RDTs. The incidence based on this sampling scheme is quite similar to the incidence based on testing everyone. But now, just to distribute the RDTs, as it's done currently, is not enough, as it has been shown in our study. Only with regular training and supervision, you can actually generate accurate data, and you can then actually use this data for surveillance. With that, at the end, I would like to thank a couple of people. So Flavia is my supervisor, Anna is the study teams in the field, the DRC team, which I've heard they are currently listening to the presentation, and the team in Niger and everyone else involved in the study. Thank you very much.